He was traveling across Goa and he noticed this Goan land is carried by ocean like a child in her arms, like a mother who takes her child once on the right, once on left. So this beautiful ocean as well takes this land of Goa once on right and once on left. So he said, Goa is the youngest child of ocean. And here we are for this 13th annual conference of Deep Foundation Institute of India, organized in joint collaboration with IGS Goa chapter, and we welcome one and all for this wonderful event to be held in this wonderful venue, Kala Academy Goa. On the outset, I request Mohan Ramanathan sir, DFI chair, and Conference Chair Professor Punanand Savarikar to escort the guest of honor for today's function, Dr. Om Prakash Jaiswal sir, as well as I request Professor Punanand Savarikar and Mohan Ramanathan sir to escort DFI India Lifetime Contribution Awardee, Professor Madhav Madhira, to be escorted on the days. Also IGS President Dr. Anil Joseph, Vice Chair DFI of India,
invaluable services rendered to the foundation industry in India and the outstanding contribution you made towards the design and execution of sustainable foundation systems. You have also been a respected teacher in the field of geotechnical engineering and at the same time contributed to the solving complex design and construction problems. That you represented India and IGS as Vice President of Asia Pacific on the board of International Society of Soil Mechanics and Geotechnical Engineering is a matter of pride.
You realize what is a wonderful thing to have grandchildren. Grandchildren are supposed to be fun without responsibility, but that's not the comparison. But another thing I would say would be, I've been very fortunate to have been recognized by, in a way, professional grandchild. DFI has been probably born because of one of the great efforts of Dr. K.S. Ramakrishna. And K.S. Ramakrishna was my PhD student. And I would say DFI was a child of Ramakrishna. And being recognized by such an organization is unique for various reasons. I've been fortunate to have been part of IIT Kanpur, where a lot of brilliant students made what I am today. Many times we don't recognize, but a faculty member is what he is because his students have done well. I've been also very fortunate to say that, there is what's called in life 7 degrees of separation. You give one individual here, another individual somewhere, you will find within 7, let's say, either one of you and Prince Charles, I can say you can find out 7 degrees of separation between somebody who knows somebody. Finally it goes to Prince Charles, or whoever it is, President Biden if you want. But I've been fortunate to have hardly 2 to 3 degrees of separation with most geotechnical practitioners, professionals, academics, etc. And we have been very fortunate to have that, and I've been very fortunate.
Attend the morning inaugural session because of some urgent meeting. He could not do it, but he made it a point to arrive here to share his valuable views on the occasion. We welcome Honorable Chief Minister, sir, requesting Dr. Punanand Savikar, Conference Chair, to present a bouquet of flowers to Honorable Chief Minister Dr. Pramod Sawant. Honorable Chief Minister, sir, always was asking the teaching fraternity from Goa to publish books, to come up with some innovative ideas, to have research-oriented programs, and to listening to his instructions. Dr. Punanand Savikar and Naik sir, Dr. Sri Narayan Naik, wrote a book, authored a book on eco-friendly sustainability. It is unfortunate, sir, that Narayan Naik is no more with us. It was his wish to publish this book, and Dr. Punanand Savikar also wrote these chapters in this book, and we take this privilege to release this book in this 13th annual conference of DFI of India. To release this book along with dignitaries on the days, Honorable Chief Minister Sir Dr. Pramod Sawant and Dr. Punanand Savikar and Sri Mohan. It's a proud privilege for all of us to have with us Honorable Chief Minister of Goa.
Annual conference of Deep Foundation, Technology for the Infrastructure Development, co-hosted by the Deep Foundation Institute of India and the Indian Geotechnical Society by Goa chapter. Today we are gathered here to celebrate the launch of book titled The Eco-Friendly Sustainability, authored by the two eminent figures at this friendly, Dr. Narayanan and Dr. Vinayak, Dr. Punanand P. Savikar. This work is a comprehensive coincidence for their expertise and dedication.
Requesting Shriman Vitthal Naik, son of late Narayan Naik, to please come up the dais and accept a memento at the hands of Honorable Chief Minister. Our regards to Naik family. Also requesting Honorable Chief Minister sir to present a memento to second author of the book, Dr. Punanand Savikar. On behalf of DFI India, I would like to felicitate Honorable Chief Minister sir, requesting Chair DFI Mr. Mohan Ramnathan to felicitate Honorable Chief Minister sir on this occasion. On behalf of IGS Goa chapter, also we are presenting a memento and gift to Honorable Chief Minister sir. A special gift is also prepared by Professor Madhav Madhira to Honorable Chief Minister of Goa. Madhav sir, can you please come up and present it? For information of Honorable Chief Minister sir, Professor Madhav received DFI India Lifetime Contribution Award for this year, and sir has prepared a special gift for you.
Kumar is Executive Vice President and Chief Technical Officer with ITD Cementation India Limited. He holds BTech and MS degrees in Civil Engineering from IIT Bombay and Auburn University, Alabama, USA, respectively. Mr. Manish Kumar has vast experience in all kinds of geotechnical activities such as piling, diaphragm walling, ground improvement, etc. And he has also more than 37 years of accumulated experience in India and in USA. Now I request Mr. Manish Kumar and Mr. Sanjay Gupta onto the stage, please.
Design, let's say, close to the limit behavior of structures, we should observe settlement of disorder of magnitude. And in the past, when delivering the state-of-the-art report at the International Conference in Osaka in 2005, we collected 63 full-scale case histories where measured settlement under working conditions were available. And some years ago, a colleague at my university increased the number by 19 cases. Now we have a database made by 82 full-scale case histories. What about the measured average settlement? If we put the limit given by Zhang and Ge, you see that in more than 90% of the cases, we observe settlement much.
Geotechnical investigation, what are the challenges we face in the tall building foundation design, mainly the Indian perspective. And thanks to the organizers and the chair, Dr. Jaikumar Shukla. An acknowledgement first, this is not only my work. I always give acknowledgement to, first of all, my teachers and my main pillar foundation, but we should have now a third component. So this is what third component of the foundation now we define as a composite foundation, which probably an example can be a combined pilot foundation, on which Professor Mandalini gave an excellent talk about that. And he also mentioned about these high-rise structures and their corresponding foundation. He also mentioned about the tallest foundation.
That the pile actually is probably capable of taking more load than what we think it should. Maybe there are situations where it could be the other way, but my point is, if you have this reality, why not look into it so that you save the length of pile, number of piles, reduce the cost of the project, time, etc. We have series of them. Here is one case, of course, where you can see very clearly it's a shaft failure, because at something like 620 in a site, when I have 3, 5, 10 boreholes, how do I estimate the allowable capacity? So we had a couple of students to do that. We looked at the variability. It could vary, and then you find out the mean and standard deviation. Or should I go for the minimum? Second would be, how do I find out the interaction between the pile and the ground? Is the pile load test only for allowable capacity, or is there something more I can extract?
Existing deep shaft, and this was already constructed. And so after 2 years, due to the client's requirement, this shaft came up. This is a small shaft. So the width of the shaft is around 2.6 meters, the length is around 15 meters, and the depth is somewhat same, it's around 23 meters. Now the one main issue was that this was very close to an existing boat tunnel. This is the boat tunnel. So, and the commissioning in this tunnel had already been done by the client. So the entire construction process was a very challenging one, and lots of things had to be considered. So this particular presentation is related to this new shaft that we had to construct. We used second pile walls comprising hard pile and soft pile with diameters of 1 meter. The higher SPT we got. So we almost got the refusal here, and the red dotted line that you can see on the screen, that is actually the tunnel crown and the tunnel invert. So a finite element model had to be done. Plane strain modeling was done. A hardening soil method was used. The hard piles were modeled as a plate element, and it was based on the equivalent section based on the pile spacing, because the soft piles were just for water.
Okay? Those differences we have highlighted before were very clear from here. On the same curve, look for instance at ball piles, some people selected different points. So, Professor Mara, when we discuss about pile-based resistance, are
we normally did all the buildings for the different departments, schools, jails, sports complexes, swimming pools, overhead tanks, and so on and so forth. Very small buildings. In fact, we do much more than this. I've been telling our engineers, please start documenting, because you can showcase what we do. In the 80s, what we did was not showcased, and even right along. This very hall is also
from many offices, like all the 4 cities in India. Mumbai is our head office. Mumbai, Delhi, Kolkata, Chennai, and out of India we are having office in Sri Lanka, Bangladesh, and Myanmar. So this is our certifications. So we are at 19th rank of marine contractor in the world. We have a substantial growth. You can see our potential growth of our revenue, continuous growth. From 22 to 24, we have almost our revenue is double due to our technical competency and constant our improvement and relationship with the existing customers. Our key and prestigious project we have recently completed. Okay, this I will skip. This recently we have completed Uranguri thermal power project, which is an 8 km run offshore. We have successfully completed India's first island breakwater in 20-meter water depth. We have done steel
TBM advancement, then 3D numerical analysis of the tunneling using EPB or earth pressure balance TBM, ground improvement proposal for the initial drive, groutability check of soil, then field grouting and verification of ground improvement. Then we will move on to instrumentation monitoring or field monitoring, conclusions and references. Introduction. In this ongoing project, the TBM launching site was located very close to the seashore. Probably within 100 meters there was seashore from the launching site. So some challenges were involved, like presence of high groundwater table almost 1 or 2 meters below the GL, then presence of loose silty sand in the tunneling zone, and the cover was very low or shallow overburden. It was around 4 meters at the TBM launching site. So these three are very critical combination, presence of loose silty sand with high ground. This is one typical model we are showing. There are several models we have studied with various sensitivity analysis, and the inner diameter of the tunnel was 5.8 meter with lining thickness of 0.275 meter. Therefore, the outer dia of tunnel was 6.35 meter. And this blue portion is the TBM shield, whose thickness is 40 mm. And this is the slurry wall we had to propose because of the loose silty sand at the TBM breakout zone. Sorry. And depth of slurry wall was 2 meter below the tunnel invert. This slide shows the 3D model of the tunnel and the different stages of TBM operation. This blue portion is the TBM shield, at the front of which phase pressure is being applied so that soil collapse does not occur. That is to stabilize the soil. And at the tail portion, tail void grouting takes place to fill the end was observed. This slide shows the development of plastic points. For the phase pressure, we have estimated around 0.7 bar at crown and grout pressure of 1 bar. These red dots are the plastic points. Now you can see these plastic points are not
lights. It's of 1200 meter length. Along with the boulevard, there is a retaining wall running all along the boulevard and the riverbed protection. As I told, like this site is in the northeastern part of the country. So before going into the design or execution, we need to get concerned with two major factors. One being in the seismic zone, high seismic zone, which will causes some extra member stresses on the